In this video, we will solve a question that deals with revenue maximization, profit maximization, and price elasticity of demand. The question is, if a firm faces the following total cost and total revenue functions, total cost is equal to 12q cube minus 44q square plus 60q plus 30q denotes the output, tc denotes the total cost, and total revenue function is equal to 300q minus 2q square. The first question is, what quantity of output maximizes total revenue? What is the value of price elasticity of demand at this output level? Okay, two things we need to find out: the revenue maximization output and the price elasticity of demand at that very output level. Second part tells us to find out the price that the firm will charge to maximize profit and also calculate the corresponding profit. And third part tells us to show the answers in part 1 and part 2 graphically. So let us try to solve this question. Okay, so we have the first question. We are being told to find out the quantity of output that maximizes the total revenue. Total revenue function is being given us as 300q 300q minus 2q square. Okay, this is our total revenue function. Now revenue will be maximum. Okay, total revenue is maximum, okay, when marginal revenue is equal to 0. Simple thing. So that means we need to find out the marginal revenue first. So marginal revenue is simply the derivative of total revenue function with respect to output. Okay, our this is the revenue. Okay, if this is a total revenue function, we have output here, total revenue here. Total revenue will be maximum at a point where the slope of the total revenue function is equal to 0. Okay, slope of total revenue function is equal to 0. By slope of total revenue function, what we mean? Marginal revenue. Okay, slope of revenue function is actually the marginal revenue. So marginal revenue is simply the derivative of the total revenue function with respect to output. Derivative of q is 1, so we are left with 300 only, and minus derivative of q square is 2q. Okay, 2 becomes coefficient and exponent is subtracted by 1. Simple thing, I have explained it n number of times. So 2 into 2 is 4q, and we set it equal to 0. Total revenue is maximum when marginal revenue is equal to 0. That means when slope is equal to 0, when the slope of this total revenue function is 0. Solving for q, so we will get 4q is equal to 300, dividing both sides by 4, so we will get q is equal to 300 upon 4, well, 4 sevens are 28, so 2 are left with 4 5s are 20, so we will get 75 as the revenue maximizing output. So when output level is 75, total revenue will be maximized. Okay, so we are done with the first part of the first question, that is to find out the output level where total revenue is maximum. With this, we have another subpart. We are being told to find out the value of price elasticity of demand at this point, okay, when q is equal to 75. Now to find out the price elasticity of demand, we should get the demand function first in terms of price. Okay, so what will we do? Okay, let me be very specific here. We need to derive the demand function from the total revenue function. We know that total revenue is equal to, total revenue function is 300q minus 2q square. Okay, simple thing. We also know that total revenue is simply price into output. Okay, so total revenue is this function, but we know total revenue is equal to price into quantity, so p into q will be equal to 300 q minus 2q square. Okay, dividing both sides by q, that means p will be equal to so if we divide both sides by q, here q will get cancelled, so we will get 300 minus 2q. Okay, this is our demand function. but we need to solve this is actually inverse demand function, okay, inverse demand function. But to find out the elasticity of demand, we need to solve this demand function for Q, okay. So this will be also helpful for calculating other stuff here, but we need to solve this for Q. So solving for Q means 2Q will be equal to 2Q is equal to 300 minus P, 300 minus P, dividing both sides by 2. Q will be equal to 150 minus 2 will become 1 upon 2, okay, P. This is our ordinary demand function here. Now, what is the formula for price elasticity of demand? And also, since Q is equal to 75, Q is equal to 75, we need to find out the price elasticity of demand at the revenue maximizing output. So what will be the price then? P is equal to 300 minus twice the output level at revenue maximization, that is 75. So we will get P is equal to 300 minus 2 into 75 go dod hath go tran hath वालों dod hath, which comes out to be, I guess it is 150. So we got the value of price equal to 50, 150. And let me write it here, implies P is equal to 50. Now what is the formula for price elasticity of demand? Price elasticity of demand, and let's denote it by E, is being given the change in the demand function, change in output due to change in price, into price upon output. This is the formula for price elasticity of demand, which implies dq upon dp means the partial derivative of this demand function with respect to price. Derivative of a constant is 0. Derivative of p will be 1, so we will be left with minus 1 upon 2. Okay. And what is p? P is 1. P is 50. We calculated it. Upon q. What is q? Q. Okay. We also need to calculate q. So q will be equal to 150 minus 1 upon 2 P. P is 50, so it is 150 minus 25, which is 125. Okay, let me see if I am doing it correctly here. 125. Change in the output with respect to price times P upon Q. So when P is equal to 50, okay, and we are being told to find out what quantity of orders, okay, so what is the value of price elasticity of demand at this output level? So Q will be equal to 75, which is 75. Okay, solving this, we will get E will be equal to minus 50 upon 75. Okay, let us solve it here. 2 ones are 2, 25s are. So elasticity will be equal to 25 upon 75, which is minus 0.3. Okay, minus 0.33 and so on. So this is the price elasticity of demand. It simply tells us if price increases by 1%, quantity demand will decrease by 0.3%. Okay, I hope I have done here the correct calculation. Okay, okay, let it be. So please verify if I have done any mistake here. Now next part tells us what price will firm charge to maximize profit. Okay, for profit maximization, firm will equate marginal revenue with marginal cost. Okay, marginal revenue function we calculated is 300 minus 4q, and what is marginal cost? The derivative of cost function with respect to q. Okay, so this is our cost function. So marginal cost will be the derivative of cost function with respect to Derivative of cost function with respect to output. Derivative of q cube is 3 q square. So 3 into 12 is 36 q square minus 2 into 44 is 88. 88 q plus derivative of q is 1, so we are left with 60, and derivative of a constant is 0. So we equate this marginal cost with marginal revenue, which is 36 q square minus 88 q plus 60. Okay, solving for q. So what will happen here, and let me write it here. We will get 36 first. Let me write this function and this mi. Okay, 36 q square. Okay, it is correct. So we have 36 q square first, then we have minus 88 q. Let me write it here, q plus 4 q. So it will become minus 84 q. Then we have transposing this here, so we have 60 minus 2, sorry, 60 minus 300, it will be 240. Okay, minus 240. So when we simplify it, okay, I don't have the space, I have calculated it. It comes out to be 3q square minus 7q minus 20 is equal to 0. Okay, using this is quadratic function, we can use the quadratic formula, that is q is equal to minus b. Let us say the coefficient of q is a, coefficient of q square is a, coefficient of q is b, and coefficient of a constant term is c. We use the formula minus b plus minus b square minus 4ac upon 2a. Okay, you know it pretty well. So q will be equal to minus b means minus into minus is plus 7 plus minus b square means 7 square minus, from the formula we have 4 into a, the a is 3, and c is minus 20 divided by 2 into a, which is 3. So it will become, when you solve this, we will get two values for the q, that is q will be equal to, or let me solve it here. So we will get, which is equal to 7 plus minus under root of, so 4 3s are 12, or 3 2s are, okay, 4 3s are 12, or I will do it like this, 3 2s are 6, 4s are 24. So we will get here 7 square is 49, 49 minus into minus is plus, here we will get 240 upon 2 3s are 6, which when we solve this, and let me write it here, then I will rub this. So we will get 7 plus minus 49 plus 240, it becomes 289. So we have 289 upon 6. Solving again, 7 plus minus under root of 289 comes out to be 17. Okay, 17 upon 6, which gives us two values for q, that is 7 plus 17 upon 6, which is 24 upon 6, which comes out to be 4, or we will get 7 minus 17 upon 6, which is negative. We will not take the negative value for quantity. So we got the profit maximizing output level equal to 4. And let me rub this out. Okay, let me repeat it here. We got two values for q here. One is 7 plus 17 upon 6, another is 7 minus 17 upon 6. 7 minus 17 is negative, so we will not take the negative value. So q is equal to 4, we will take that very value. And let me rub this out now. When we solved this, we got q is equal to 4. So profit maximizing output level is 4, but we are being told to find out the price. Okay, if q is equal to 4, what will be the price? P will be equal to, simply plug q is equal to 4 into inverse demand function. This is inverse demand function, 300 minus 2, the value of q is 4, so 300 minus 8 comes out to be 292. This is the profit maximizing price. Next part is to find out the profit. We know profit is equal to total revenue minus total cost. Total revenue function is being given us 300q minus 2q square. To this we subtract the total cost function, which is 12q cube minus 44q square plus 60 plus 30. Okay, solving it, that means pi will be equal to 300q minus 2q square minus 12q cube minus minus into minus is plus 44q square minus 60q. Okay, here we have q. Okay, let me write here 60q minus 30. Okay, so profit will be equal to 300. Profit maximizing output is 4, so in place of q we have 4. Similarly, minus 2q square means q square is 4 square, so 4 square is 16, so we will get 2 into 16 minus 12, 4 4 are 16, 4 are 64 plus 44, 4 4 are 16 again, minus 60 into 4 minus 30. When you solve this, we will get profit equal to, I don't have the space here to solve that very stuff, we will get 834 is the profit. Okay, so next part tells us to show your answer graphically. Okay, so how do we show? In case of revenue, as I have told you, if I draw the graph here like this, we have the total revenue function like this. Okay, this is total revenue function. We have output here and total revenue here. Profit will be output will be, sorry, total revenue will be maximum when marginal revenue is equal to 0, when the slope of the total revenue function is equal to 0. So that means when q is equal to 75, we calculated that very thing. Okay, for profit function we can also draw the profit function, but I don't have the space here. It will look like this. Okay, since it is a cubic function here, so it will be like this in the second quadrant. We are not concerned with the second quadrant. Let me draw it here. Profit maximization, sorry, profit function will look like this, okay, so profit will be maximized when we produce 4 units of output, and correspondingly profit will be equal to 4, what is the profit that we calculated, 834. Okay,